Hi, this is Mrs. Slauson. I am one of the Algebra 2 teachers, and this is the review for the Chapter 5B test, and we're going to be starting out with graphing. You need to pay attention to what type of graph you are working with. So on number 1, we have a square root, and number 2, we have a cube root, and that's going to determine what points we choose because of the domain issues. So starting at the square root, if you remember, we talked about what numbers can we take the square root of in our head, and their points will still fit on our graph. So we chose 0, 1, 4, and 9, and we took their square roots and got 0, 1, 2, and 3. And so those are the points for the parent function, the square root of x. Now what we're going to do is start to apply these transformations. So kind of going left to right, the 2 is going to make it stretch 2, the 1 is going to make it go right 1, and the 3 is going to make it go up 3. So what I do is I make a new column in my t-chart, and I start with the stretch, compress, and flip if there is one. And you do that by taking the old y and just applying the stretch, compress, and flip values. So I'll be doubling those y's to get 0, 2, 4, and 6. So I won't actually even be graphing that set of y's. I'll be graphing 0, 0, 1, 2, 4, 4, etc. So I'm going to do this in 2 steps. I'm going to first show you the stretch on the graph. So there's 0, 0. Here is, 1, 2. There is 4, 4. And then we have 9, 6. So what's going to happen now is these points are going to go right 1 and up 3. So 0, 0 is going to go right 1, up 3, and end up here. 1, 2 will go right 1 and up 3. 4, 4 goes right 1 and up 3. And same with 9, 6. So where it started at 0, 0, it now starts at 1, 3. And still goes to infinity for x and infinity for y. So now I can answer the domain and the range. So starting with my domain, which is the smallest x to the biggest x, I have from 1 to infinity, in bracket with parentheses, and the range is from 3 to infinity. Those are my y's, smallest y to biggest y. Positive interval, the whole thing is positive. It's never not positive. So remember, we're describing when y is positive, but when we use the answers, when we write the answers, we're going to use the x values. So it starts at 1 and it goes to infinity. And 1 is part of the positive area, so I will be putting a bracket around it instead of parentheses. The interval of decrease, this is not happening. Don't leave it blank. Show in some way that you understand that it doesn't exist. And then end behaviors, remember that's all this writing. So in this one, x is going to infinity. As it does, f of x is also going to infinity. But when you do, as x approaches negative infinity, that doesn't happen in this graph. So what you need to do is don't leave it blank, do that. You can put not applicable. Some teachers say does not exist. Whoops. Whatever they've asked you to do. Okay? All right, let's move to number 2. So in number 2, as a cube root function, I'm going to choose very different points. I'm going to be choosing numbers that I can take the cubed root of. So those would be -8, -2, sorry, not -2. -1, 0, 1, and 8. And their cube roots are -2, -1, 0, 1, and 2. So those are the parent function points that I would use to fit on this graph paper. So now what I'm going to do is state the transformations. Just 1 second, I got to plug in my computer here. Just a moment, might switch around on you for a second. Okay. So the negative is I will have a flip. All flips are over the x-axis. We are not flipping over the y-axis. The 3 is going to make it go left 3, and the 1 will make it go down 1. So I'm going to, again, first apply my stretch compress, which doesn't happen, but a flip does. And so I will take the old y's and just take the opposite of them. So -2 becomes 2, then you get 1, 0, -1, and -2. So again, I'm going to do this in 2 steps. I'm going to graph these points first. So here is -8, 2, and then we've got -8, 1, 1, 0, 0, 1, -1, and 8, -2. And now what I'm going to do is apply my left, right, up, downs, etc. Okay, so sorry, I had to take a phone call. So now I'm going to finish my transformation. I'm going to make these points go left 3 and down 1. So going back to that negative 8, 2, it will be going left 3 and down 1 and end up right there. And just all the points, left 3 and down 1, you just have to count. And finally, 8, 2 will go left 3 and down 1. And now I'm going to connect those. I don't know how well you'll see. Well, you'll see it pretty good. And again, I always mark my arrows. So I'm going to have negative infinity to infinity, because as x is going to the left, that's negative infinity, but the y's are going up. And as I go to the right, where x is going to infinity, the y's are going down, so you'll be putting negative infinity here. So domain and range, it doesn't matter when it flips, stretches, compresses, left, right. This is always the domain in a cube root function. And it also describes the range in a cube root function. So that's a no-brainer on those two. Positive interval. So again, we're looking to see when y is positive and where y is decreasing, but we're going to give our answer in terms of x. So as I go left to right, my graph, y is positive until I get to the point 4, 0. And at 4, 0, it's not positive or a negative, but then when you continue to the right, y's switch into being a negative value. So I'm just going to stick to this yellow highlighted area. And it starts being positive with negative infinity and ends up, I'm sorry, that was a negative 4, at negative 4. And I'm going to use parentheses around negative 4 because it's not positive or negative there. It's kind of like in this 0 no man's land. So I don't want to include negative 4, and that's why I use the parentheses. And then as far as decreasing goes, well, as you go left to right, the whole thing is decreasing. It's always, the y's are decreasing. So that'll just be negative infinity to negative infinity. Now we can do the end behaviors. So I'll start with going to infinity. And x is going to infinity, but f of x, your y's are going to negative infinity. That's this. And then I'll do it again as x is going to negative infinity, which it is. And I'm going to write what my y's or f of x is doing, and that's over here. It's going to infinity. All right, so that's the first page. Let's move on to page 2. So in problem 3, we're just incorporating a little bit more with graphing. You don't need to put anything else with domain and range. We're just going to practice graphing. So again, with the square root function, we will need to realize that the points we're going to be using for our t-chart are the ones we can take the square roots of. So 0, 1, 4, and 9. And when you take those square roots, we get 0, 1, 2, and 3. So I will start looking at the transformation. This, I'm not going to write all the words out, is going to make it compress. The 2 will make it go left 2, and the 4 will make it go down 4. So I'm going to start by making my new t-chart and applying a new y column and applying the compress. So I'm going to take the old y's and take half of their value. 0 stays 0, but 1 becomes a half, 2 becomes 1, and 3 becomes 1.5. So I'm going to graph those. Some of those will be a little bit tough on this format, but just bear with me. So here's 0, 0. Again, I'm going to do this in 2 steps. That's about, 0.5. Here's 2, 1. And then 9, 3 becoming 9, 1.5 is about there. So you can see it's compressed. It's definitely flattened out from the parent function, but now I'm going to take them and go left 2 and down 4. So 0, 0, left 2, down 4. The half, left 2, down 4. Just do the best you can. 2, 1 though, left 2 and down 4. And then the 9 and 1.5 can go left 2 and down 4. So now instead of starting at 0, 0, it's going to be starting at negative 2, negative 4 right here. And then continuing on and infinity, infinity. And then, with this information, you could figure out your domain and range and etc. Okay? All right, let's end our graphing with number 4. And this time we're going to write a function that flips across the x-axis, stretches 4, and goes to the left 3. So the flip across the x-axis is what I'll start with first. That's a negative. A stretch of 4 would be written next. And then left 3, anything left, right, I've told you guys is in the house, and our house is a square root, and I will write it as x minus 3. So when you think about the domain and range here, right now in a parent function, it starts at 0, 0, and goes to infinity. But since this shape is going to be going to the right 3, it won't be starting at 0, 0 anymore. It will be starting, I'm sorry, it was to the left 3. Let me back up here. So first, to the left 3 means this should be, I wasn't reading, plus 3. And that won't be like that. We'll be going to the left 3. So that means it's starting not at 0, 0, but at negative 3, 0. And then going towards the infinities that you see. So my domain is going to be changing. Rather than 0 to infinity, it's now starting at negative 3 and going to infinity. But my range will stay the same because it didn't shift up or down. So it starts at 0. And actually, you know what? Again, I'm just not paying attention. So hold on. We're going to fix that. So let me back up. All of this is good except for my domain and range. So let me start over. So normally it starts at 0, 0. And goes this way. But first it's going to flip, which is going to cause it to go like this instead. So now it's going, instead of infinity, infinity, it's going to be infinity and negative, infinity. And now I'll apply the left 3. So it's still going to be going left 3 and starting at negative 3, 0. But now this is your shape. So let's talk about domain. Domain is still negative 3 to infinity. My apologies. I forgot the flip. But the range is different. Now we have a smaller y and a bigger y. So our y's are 0 and negative infinity. And I will be putting negative infinity first because it's smaller, and then the 0. So again, I'm sorry, I did not apply the flip when I did this the first time or even the second time. So just backing up. Let me explain that one more time so you can fast forward. It normally starts at 0, 0 and goes to infinity, infinity. The flip is going to make it go like this. And then the left 3 is going to turn it to go left 3 and be like this instead. So we're starting again at negative 3, 0, and then this is infinity, negative infinity. And it's the light blue one that I based the domain and the range on. All right, let's go ahead and move on to the part with domain and looking at the functions.